One final property of logarithms is log base a of m raised to the p equals p times log base a of m. Basically, when we have a logarithm out front and we have an exponential expression, we can take that exponent and drop it down in front of the log. This property is really quite helpful later when we're solving equations. In this case, we're going to expand this logarithmic expression. Up first, recognize that we have a product inside the argument. So using the properties from earlier, we can expand that product into a sum of logs. And now using the new property, we have this exponential expression. We can pull that exponent down in front of the log. That will give us 2 log base 5 of x plus log base 5 of y. In our next example, notice we have a quotient. We know from earlier that a quotient, when we expand it, will become a difference of logs. And now we have an exponent. We can bring that exponent down in front of the logarithm. 2 natural log of e minus natural log of 7. And we know that the natural log of e is really 1. So 2 times 1 is simply 2. Then we get minus natural log of 7. In this example, notice we have a lot going on. We have a product in the numerator. We also have a big quotient and an exponent. Let's take care of the quotient first. To do that, we will break it apart, expand it using subtraction. Next, we can break apart this product using a sum of logs, log 100 plus log x. And at the same time, we can go ahead and take care of this exponent. We get minus 3 log y. We can actually simplify this first logarithm. Recognize that we don't see a base, so the base is 10. 10 to what power is 100? That is 2. So our final expanded version is 2 plus log of x minus 3 log of y. In this example, we have a product in the numerator and a product in the denominator of the argument. Let's start by getting rid of that quotient. We can do that by expanding and using a difference of logs. So we have log base 2 of p squared r minus log base 2 of 8 square root z. Next, we'll take care of the product here and the product in this argument as well. That is log base 2 of p squared plus log base 2 of r minus log base 2 of 8 plus log base 2 square root of z. Now we have to be careful here. Notice that this log is being subtracted. And when we break apart this log, when we expand it, expanding the product here, we need to be careful to make sure that we put that in parentheses so that we notice that we need to distribute that negative sign, because this sum is really, when we condense it, a single log. So when we expand this log, again, we need to make sure we put it in parentheses so that we know to distribute that negative sign. Up next, we'll go through and take care of any exponents we see. This first log has an exponent on the argument p, so we can pull that 2 down to the front of the log. 2 log base 2 of p. The second log does not have an exponent other than 1, so we can just copy that. The next log doesn't have an exponent other than 1, but we can actually simplify it. Log base 2 of 8. 2 to what power is 8? That is 3. And we need to make sure to make it minus 3. And you may not see an exponent on the square root right away, but remember that the square root is really the 1/2 power. So we can think of this square root z as really z to the 1/2 power. So there's an exponent that you just don't see, z to the 1/2. So we'll bring 1/2 down in front of the log and recall that we need to subtract that. We need to distribute that negative sign. So we have negative 1/2 log base 2 of z. And now we have the fully expanded version. Finally, in this example, we have a big product. We have 10 times x cubed times the square root of x plus 1 inside the argument. So that's going to be a bunch of addition when we expand this log. Log of 10 plus log of x cubed plus log of the square root of x plus 1. Recall that the base is 10 when we don't see a number there, so we can actually simplify this one. 10 to what power is 10? That will be 1. The second log has an exponent. We can bring down that exponent, giving us 3 log x plus this argument has a square root on it. We don't see an exponent, but like last time, that's really x plus 1 raised to the 1/2 power. So there's an exponent of 1/2, we just don't see it. We can bring that 1/2 down in front of the log, and then just make sure we put the argument in parentheses since it has more than one term. And now we've fully expanded this log.